All right, today we're going to put on our detective hats and go on a bit of a digital investigation. Our mission? To crack a software protection system and uncover a secret serial key that's been hidden deep, deep inside its code. Think of it like the ultimate digital puzzle box, right? You've got this locked program, but the key is actually hidden somewhere inside the lock itself. So where do you even start looking? Well, that's the exact question we're going to answer today. Okay, so first things first, let's lay out the challenge. We are facing a program that needs a serial key to unlock. Our job is to figure out what that key is, not by guessing, but by carefully picking apart the program's inner workings using a tool called x64dbg. And here's a really important point. Our goal isn't just to find the key, it's to derive it. What that means is we have to actually understand the logic the program uses to check the key so we can build the correct one completely from scratch. You know how every great detective story starts with that one single clue? Well, it's the exact same thing in the world of reverse engineering. It all begins by sifting through the program's data, just looking for any little piece of text that could give us a hint about what's going on behind the scenes. So our first move is basically just some simple recon. We load the program into our digital magnifying glass, which is x64dbg, and we search for any string references. That's just a fancy way of saying any piece of text that's hidden in the code. We're pretty much just looking for any internal notes the developer might have left behind. So we're digging through all of this noise, and then boom, something catches our eye. It's a piece of text that looks totally out of place, kind of like a password, but scrambled. This, right here, is our first big break in the case. And this is it, khoor 42. Now, here's the twist. This isn't the key itself. It's actually the result the program is expecting after it scrambles whatever we type in. This is the target that we need to hit. All right, so finding the clue is just step one, right? Any good detective knows you've got to follow the trail. Now that we have our target string, we need to figure out where in the program's code it's actually being used. To do that, we use a technique called a cross-reference. Honestly, the easiest way to think about it is like that find all feature in a word processor. It just scans the entire program and points us directly to the exact lines of code that are interacting with our clue, khoor/42. And bam! Just like that, following that trail leads us exactly where we needed to go. The cross-reference pinpoints the precise function where the program takes our input, does something to it, and then compares it to our target string. We've just found the secret formula's hiding spot. Okay, so now we're staring at the raw assembly code, the program's most basic instructions. And yeah, I know, it can look a little intimidating, but don't worry, we only need to figure out two key operations that are happening right here. So the program's logic is actually a pretty simple two-step dance for every single character we type in. First, it adds 5. Then, second, it performs something called a bitwise XOR with the number 31. You could just think of XOR as this kind of cool digital scrambler. It's super easy to reverse, but only if you know the secret number. It's a simple but pretty effective way to hide what's really going on. So if we boil all that down, we get this one simple formula. It takes our input, it adds 5, it XORs it with 31, which is just 1F in hexadecimal, and the final result has to be khoor 42. We now know exactly how this lock works. Okay, this is cool. We know how the lock works, but that's only half the battle, right? We need to build the key. And to do that, we literally have to take that formula and run the whole thing backward. This is the real heart of our detective work. And it all boils down to this one simple but really powerful rule of logic. To undo a bunch of steps, you just have to apply the opposite steps in the reverse order. This is the golden rule that's going to let us crack this code wide open. So let's just walk through this. The program went forward by adding 5 and then doing an XOR. So to go in reverse, we have to start at the end and do the opposite. So our first reverse step is to do an XOR. And our second step is to do the opposite of adding 5, which of course is subtracting 5. And there you have it. That is our key generating formula. To get the original secret key, we take the target string, khoor 42, we apply that XOR operation to every character, and then we just subtract 5 from each of those results. This will perfectly undo everything the program did. Okay, the moment of truth. We followed the clues, we decoded the secret formula, we reversed it, we have done all of the hard detective work. So, what happens when we apply our brand new formula to every single character in khoor 42? What's the key? And the answer is ORKAH7. That's it. That is the one and only serial key that when you run it through the program's logic produces that target string. The puzzle is solved. Case closed. So what's the big takeaway from all this? I mean, cracking that key was definitely fun, but the real prize here is the set of detective skills we just used to get there. These techniques, they're really the foundation of all reverse engineering. The point is, you now have this awesome reverse engineering toolkit. You know how to find clues by looking for strings, you know how to follow those clues using cross-references, how to actually decode a program's secret formula right from its assembly instructions, and most importantly, how to reverse that logic to find what you're looking for. So yeah, we successfully cracked this digital lock. But what happens when the next lock is designed to fight back? What if a program knows you're watching it and it actively tries to mislead you with anti-debugging tricks and other traps? Well, that's a whole different level of detective work, and a story for another day.